right. For those of you at home, forgot to record this with volume in third, and now I'm recording it after starting the problem, but I'm going to do another whole problem so you'll see this. Did you get him on camera too? What did you say? No. Well, it's possible. Was it off color?
No, it was a good one.
You want to share it again?
It was a good class. Well, you said you did it without volume, so I said you need to add a DX to it, you know?
Oh, I didn't hear that part. Yeah, it might have picked that up. All right, guys. So once again, hey, as you can see, I'm going to walk through this real quickly just to hopefully hammer it in. Okay, so if I have a region, right, a region, and I want to rotate that region about an axis. As I rotate it, it creates a solid. I want to find the volume of that solid. And as you can see, when I rotate it, and by the way, this is a top function f of x, and this is the bottom function g of x, which represents that. And these are just the edges from A to B. You can see that when I rotate this thing, okay, when I rotate it, it creates this solid right here that has a part in the middle that I need to get rid of. So what I'm going to do again is ignore the part in the middle and say, how would I find the area of the cross section? So it's kind of like cross sections like we did before. I would still need, if I cross section this, I need that radius. And that radius is not top minus bottom of the region that was shaded. It's the outermost function to the axis. So if I subtract the outermost function and the axis, I get the big R, the big radius. And then I can pi r square it to get the area of this circle. I can dx it to give it width and integrate from A to B to give me volume. But then I got to go back and get rid of the hole running through the middle. The hole running through the middle is this part. To get rid of that, I got to know that little radius, right? And the little radius has nothing to do with the outer function, it only has to do with the innermost function, the one closest to the axis. So I go innermost function, which we call g, minus the axis to get that length. Okay? And then again, pi radius squared is the circle, dx it to give a little width, integrate from A to B to give it volume. And you're taking the whole area and subtracting the hole running through the middle. And we can do this all day. And today, all of our axes will be horizontal. Now, if I give you a vertical axis, guess what happens? We got to be thinking not right minus left so much, but outer minus axis, but it will have to be in terms of y. It'll be a dy problem. And a lot of people don't like that. So I'm going to do something that APCalc does not require. And I'm going to show you another method called the shell method. And the shell method allows you to find volume with vertical axes without ever changing it, and you can leave it in x. You can leave it as y equals something x. So you never have to go and make it x equals something y if you know the shell. And the shell's not hard to deal with. And the nice thing about a shell is like peeling off layers off a roll of toilet paper. Once you get to the hole, what happens? The toilet paper's gone, right? So the shell just peels off layers until there are no more layers. Whereas this, you're over calculating and then getting rid of the part that you didn't want. On a shell, you just peel off the layers until you're done, and then you're done. So you can always do shell, well, not always, but unless it's a weird function, you can do shell with one function. I mean, one integral, except two. Now, last thing, when you look in your book's notes, and also sadly, sometimes in AP, they don't write it like this. What they do is this. You'll see A to B, 1 pi, and then what you'll see is f of x minus axis squared minus g of x minus axis squared. And then you'll see one big parenthesis around all of that dx. They like to combine it to 1. And I taught it that way for a year or two. And then I read this article on the AP website, ironically. On the AP website, some teacher who taught for 30 years, APCalc, she goes, when I started doing this and not this, my averages jumped a letter grade. And I kid you not. I was like, well, let's try that out. So the first 2 years I taught, my area and volume averages were 86, 85, 87, whatever. I taught it this way. 96, 97, literally overnight. I didn't do anything different except say whole. Actually, I did the whole minus whole. I started that a couple years ago. People still smile like, oh, whole. But, and don't go to college going whole minus whole, or you'll look foolish. But that helps people think. Right here, my averages are always upper 90s. Okay, and hopefully that'll be the case for you guys too. So let's just do a couple of these. But remember, in no way will you ever be going top function minus bottom function on this. You're not going to be doing it. Like, you tell me, would the area be the same if I took this right here, say 2 inches, and I rotated it about this? Would that be the same as taking 2 inches and rotating it like this? No way. This is like a 2-inch thick donut. Fine donut, right? But I would rather have a 2-inch thick donut that was like that. That is if you wanted more donut, right? If more donut is better, I would rather have 2 inches like this. So if you go in here to do your radius and you go F minus G, and then you spin that, you're getting a little volume. And you're going to wonder where your hole went. So it's always outer function minus axis, inner function minus axis. And then the great thing about that, if you get this set, then look what happens when I move my axis. If I move my axis up here and then revolve it, right? I get a totally different looking figure, don't I? But the math still works. Now, in this case, here's my figure, right? How do I find the radius right here, which is the big radius? Outer minus axis, except technically I should do what? Axis minus outer. Because we always do want to go from high to low, right? When we subtract, so we end up with a positive number. But will it matter? I'm squaring it. Now, I don't know how AP treats it. Their keys don't say it doesn't matter. Their keys say it a certain way. I give you credit if you have axis minus f of x or f of x minus axis, because the math's still right? Because you square it, it becomes positive anyway. But then you probably, if you really wanted to be right about it, you'd go axis minus outer. And then for the little bitty hole in the inside, how do you get rid of that? Axis minus inner. So that would be the only change in this, depending on where the axis is. Are y'all seeing this? Now, again, if I put a vertical in there, whatever. Also, I will never give you the axis of rotation running through your shaded region. That would be weird. I don't even know if it does that. Let's see. I put the axis running through it. Yeah, that's kind of weird. Because what happens is you only have a hole right here. See that? This overlapped on itself. So you didn't have any hole there, just a hole there. AP won't do that. I won't do that. It's a good question. Be a great little bonus question. I've never done that. And AP has never done it. So I can expect that they never will, since they've been doing this for 40-something years. Are y'all kind of seeing what I'm talking about? So the axis will always be outside it. And if you do that, you'll always have a hole minus a hole. And we call this method the washer method. And you know washers, like when you go to Home Depot and you buy nuts and bolts and washers, you know? You track anything? It's got a hole in the middle, so they call it the washer method. Now, there is also a method called the disc method. The disc method just means there's no hole, right? It would just be a disc. Without a hole, it's just a disc. So the method is a lot of times called disc washer, but I just think of it as washer. Okay, so it might be labeled disc washer on your notes, your assignment sheet. Did I give you an assignment sheet? Not yet. On the assignment sheet I'm going to give you or whatever, you're going to see washer, disc, and shell or whatever. But the bottom line is a washer and a disc. It's the same method, except if there's no hole, there's no hole. Don't subtract anything. When would there be no hole? Like this. What if I put the washer, the axis right at y equals 0? And you can see when I revolve it, see, there's just no hole in the middle. But why was that? Because the axis was the what? The innermost function. Are you with me? So when the axis is the innermost function, what do you end up getting? When they're the same? 0. The integral of 0 is, right? Just some random constant ends up being 0. You tracking with me? Okay. All right, so let's do a couple of these and we'll see what you know. And I hope you don't have to memorize this. I kind of hope it makes sense without memorizing, but anyway. Get out of there, no save. And okay, so there's some notes on this. You're welcome to look at the notes. The notes kind of mix up vertical and horizontal spins, all that. But we're going to jump to hold on. Okay, let's look at example 2. I've got 18 minutes. So how about part B, example 2, part B. So I'm going to draw a picture of this, hope it makes sense. Here's the graph of f of x equals 9 minus x squared. I would hope that you could sketch that. Do you know how to sketch that? What kind of graph is 9 minus x squared? It's a parabola. What's the x-intercept? 3 and what? 3 and negative 3. How do I know that? Because I'm plugging 0 for y and solve, I get 3 and negative 3. Okay, what's the y-intercept? 9. So it looks something like this. You probably knew it was a downward parabola because it was negative, right? So I have this parabola, but it says on the interval from 0 to 3, so I don't even need that part. 0 to 3 is this, right? And then it also says the line y equals 12. So here's y equals 12. So it says the volume obtained by rotating the region between that graph and 0 and 3. So I guess I'm just rotating this region. Everybody with me? What am I rotating it about though? Y equals 15. So here is y equals 15. So technically, here's what I'm doing. I'm taking this region and I'm rotating it about that line. And that's going to give me this region, isn't it? And I rotate it. Except when I rotate it, you can see there's a hole on the inside, can't you? I'm rotating it about this whole thing. Now, that's not awesome, but it's not terrible, right? You kind of get the visual? So I'm rotating this thing around. How do I find the area of a cross section? So I'm in pink right here. I'm putting this cross section in there. What do I do here? So I got to find the radius of the hole. So ignore the hole, big circle. How do I find that radius? Here's the axis, y equals 15. Technically, there's the function f of x. So how do I find the length from here to the outer function? 15 minus f of x. Are you with me on that? Could be f of x minus 15, but technically, since we normally like to go top minus bottom, bottom minus top, I want to go 15 minus f of x. That gives me a positive value, but again, even if you got a negative value, you're about to square it. Now, by the way, when I do when I do the shell method, it will matter. So it's a better thing to get in. When the axis is up here on top of the shaded region, you ought to start with the 15. So I'm going to go 15 minus the outer function, outermost function, right? That gives me what? Radius. Pi radius squared gives me area. Dx, it gives me a thin volume. Integrate it from 0 to 3. And this is my hole. Now, I want to get rid of what? This. Now, if I'm really sticking to my guns, I go axis minus inner. What's the axis is 15. Inner is y equals 12. Can you just say 3? Of course you can. In fact, on the AP test, a lot of times you won't even, like when you look at the key, you don't even see anything written as an integral because that's a cylinder in this case. And people will go, well, that's 27 pi. That's pi r squared with a height of 3. Pi r squared, 9 pi times 3, 27 pi. But that's what you're going to end up getting when you take this and integrate from 0 to 3? You get 3 squared is 9. The integral of 9 pi is 9 pi x. From 0 to 3, you plug a 3, you plug a 0, you subtract, you get 27 pi. And I want to subtract that whole. Not too bad? And that is shown, if you want to look at that key, the solution to that was right here, part B, written out kind of extensively. And I just got you to, what, right here? Right there. But if you wanted to keep going, you could get to there. All right, let's look at a classwork problem. What about number 4? So we're looking at number 4. Everybody see that? Yes, y'all find it? You care to find it? So help me out if we're just saying set it up. Number 4. So ignore these little boxes, by the way. That's just the way the book, I borrowed this from some book, and they were explaining that you're really finding this right here, and you're rotating they call it a solid. You're rotating a solid around, it creates a disc. I like to just think about it as I'm finding a cross section, and then I'm giving a little width. But that's all they're doing. You can ignore those. Don't overthink it. Okay? So right here, I'm rotating about the line y equals -1. So here's my y equals -1. I'm rotating this shaded region right here, this whole shaded region about that line. So help me out. When I rotate it, I get a big solid with a hole running through the middle. Can y'all see that? Would I have a hole? Where would this axis have to be to not have a hole? It would have to be y equals 0, wouldn't it? Or the x-axis. If it was right there when you rotate it, then you don't get a hole. Then you can leave off the hole and just do the hole. So help me out. How do I do the first cross-sectional area? And the top is, so 9 minus x squared minus what? -1. Function minus axis, that's your radius. So that gives me that length right there. Now that length is changing as x changes, but we're not worried about that. The integral does that. Now what? Well, hold on, that's just radius. So I've got a pi r square it. Make sure the whole thing's in parentheses because the whole thing's my radius. I got to square the whole thing. If you get the parentheses, then you miss your point because you're not squaring everything. You're just squaring the -1. Now that's your cross section of an area. So now you got to dx it to give it some width and integrate from. Happens to be 0 to 3 again, and that represents your whole. Now what do? Subtract your what? That part. That's the part that was on the inside you got to get rid of, right? So now what do? Inner minus axis. Now if you can eyeball and go, well, the length's just 1. Well, then use 1. If you can't, stick to your guns. 0 minus a -1. Inner minus axis. Square, pi it, dx it, integrate it from 0 to 3. But if you see that the radius is never changing, then you're fine to put 1 in there. If I look at this and go, I'm down -1, that length is always 1. Fine, do pi 1 squared. 1 squared goes away too. You could just do the integral of 0 to 3 of dx. You integrate a 1, what do you get? An x. So it doesn't have to look like this. It probably shouldn't look like this on your AP test. You ought to probably clean those up when they're just end up being a whole number. Because if this was if they were asking you to write this out or circle the expression that matches this, you're not going to see this. What you are going to see is probably this. And hopefully you go, oh yeah, that's +1 squared. That's just a 1 dx. So hopefully that you would know was this, but whatever. You with me? What about number 5? People miss number 5 all the time. Is we're going to make this a non-calculator problem, and you're going to work it all the way out. So you're rotating about what? Y equals 2, which is maybe somewhere up here. So as I spin this, the first thing I want to find is what? I'm spinning it around this. If I'm finding the hole, how do I find the radius? The outer radius. Are y'all stumped? What? The bottom function? Okay, is the bottom function the x cubed or the x squared? Why would it be x cubed? Think about it. If that's x squared and that's x cubed, how can I, if it is, or if you're wondering, how could I determine which one's smaller? Plug in a half or some number in between 0 and 1. If I plug a half in there, I get 1/8. If I plug a half in there, I get 1/4. So this is clearly higher here in the inside. Are you seeing that? Now out here, the x cubed is going to be higher, right? Because if you plug in a 2, you get an 8 versus a 4. But in here, that's on the bottom. So my first radius is what? If this is y equals 2. What? 2 minus x cubed squared pi. Then dx integral from 0 to 1. And then how do you get rid of the whole? 2x squared pi dx integral 0 to 1. Great, you got your 2 points for setting it up. Now you got to integrate it. How do I integrate that? Without a calculator?
No.
No, thank you.
Can you do a U substitution with that stuff on the inside? You can try, but sadly it's not going to work. Foil it. So when I square that, I get 4 minus 4x cubed plus x to the 6th pi integral 0 to 1. What do I get here? 4 minus 4x squared plus x to the 4th. 0 to 1. How do I integrate that? 4x minus x to the 4th plus
X over 7.
x to the 7 over 7. Don't forget the pi from, and you have to write vertical line 0 to 1. Are y'all hearing me? Some of you got a little bit better about that in this past test, about writing that, but some of you still stink at it. When you integrate, put that 0 to 1, and then over here, what do you get? 4x cubed over 3, x to the 5th over 5, 0 to 1. And then kindly enough, they gave you 1s and 0s. I plug a 1 in, I get 4 minus 1 plus 1/7 minus pi times 0. And then here, be careful, I'm subtracting this. So I plug a 5 in, and I get 20, not a 5, I plug a 1 in, and I get 4 minus 4/3 plus a 5th, right? But then when I subtract, to plug the 0 in, I also got to subtract this. So what does that make that? Put the whole thing in parentheses. 1, 0. But when you subtract, what does it do in the middle? Changes that sign. And plugging a 0 in there just gives me a 0, but good thing for you. Yeah, that good thing for you, that'll cancel. So you would have to do the math on this, but look, if you think about it, 4 pi minus pi plus pi over 7, and then minus 4 pi plus, sorry, that's pi times everything, pi over 7, right? Minus, this is 4 pi plus 4 pi over 3 minus pi over 5. Some of that stuff might cancel. Make it a little bit easy on you. I don't know. Probably not.
Not the worst thing.
But not the worst thing ever. Right. Are y'all seeing this? All right. I'm telling you, if you stay on this, it's a nice A you can have on your last grade of the 9 weeks. Oh, and another thing, I'm thinking about doing your review differently. I think the real place where you get better is reviewing these tests, going over old practice exams. And right now, I don't have time to give you more than one. We just out of time. So what I may do is just can what I normally did, And I might just start giving you practice tests from day one, and I'm gonna count every one. Like to start out, but as your scores get better, I will, like if I am able to give you 4, then I might keep 2 of the 4 best ones in each category. If I'm able to give you 5, I might keep 3 of the best 5. So this first one will probably be a practice one. Probably won't count for much because most people end up dropping it because you will get better. But if you don't care about learning what you miss, you're going to be doomed to repeat your mistakes. So I'm thinking about doing that, and I think I can get maybe 4 or 5 practice tests in full length. And if I do that, you're going to be in really good shape. Oh, I also have this thing called 5 Steps to a 5, this book, and I bought one for everybody. I'm going to hand those out at the end of this section. And if you want to like research stuff, it's got great notes and reviews, so you don't have to dig through your stuff. You can have a table of contents and jump to limits, or jump to related rates, or jump to Newton's law of cooling, and it really gives a good review on that kind of stuff too. All right? Hey, do a little homework, especially if you stunk on this last test.
Yeah.
All right? Hey, here's your assignment sheet. Sorry if you packed that. Hey, don't forget to grab one of these.
Hey, you saw Steven Robinson on Boston? Oh, yeah.
Hey, sure, grab one of these.
He scored all 3 goals from my partner. Yeah.
Who was to her?
Everybody got one?
Are you gonna give us some more APCalc?
You what?
Are you gonna give us some more AP problems?
Am I giving you some more? Oh, I do need to do that, yeah, but we didn't do any tonight. Okay, good. Yeah, I got a big stack of that.
I have a question about the test. Can I run it?
Sure.
It was the bonus.
Right.
I wrote the integral from 4 to k instead of k to 4.
4 to K would be right.
Yeah, and I got 4 because I manually integrated.
If you got 4 points, you got all points.
I got 2.
Oh, and you didn't get the right answer?
I put 4 for the right.
Oh, it was 9.
Oh, it was?
Yeah. Did you do this? What did you do?
I did the integral from 4 to 16 and got 40 for that.
That's correct.
Half of that would be 20.
Right.
I split it in half, and I did the integral from 4 to k is 20.
Oh, I bet you did the integral from K to 4 is 20. Because 4 to K is right. But if you do the integral from K to 4,
You get a negative.
you get a different answer. Yeah.
But I'm pretty sure I put 40 there.
I can look. Yeah, but the answer was 9.
No, I got 4 then. Yeah, because 4 wouldn't make any sense. You get 0.
Can I get a button?
Sure.
Because the integral from 4 to 4 of anything would be 0. So that doesn't make any sense.
Okay, so you did. Oh, yeah, you did. Oh, wait.
Yeah, but I still know 4.
Why did I write K to 4? You do want to do 4 to K.
Either way, the answer is still right.
Yeah, hold on. Why did I change that? Hold on. So you did 10x to the negative 1/2.
Because the graph is like
So
something like, what is it? A k over like some
20. Okay, first of all, I don't know why I did. So you did, let's just figure this out. You got, this is 10x to the negative 1/2.
Yeah.
So it's x to the half divided by half multiplied by 2 is 20 from 4 to k. So if that's the 4 to k.
Oh,
So you
maybe
got-
I switched that and put.
No, you did that right too.
Uh,
You plug that in there, and then you plug the 4. So you should have gotten k minus,
what's the 40?
and that's a 40. Oh, and then you add a 40, and you get a 60.
Oh, okay.
Okay, no, so that, I don't know why I wrote that. No, you're right there, and you're right there,
Yeah, that
and you're
really-
even right there.
Yeah.
So you just, at that point, you needed to get 60,
Yeah, 16.
which would have given you 3.
9, square root of 9. Okay.
Yeah.
Yeah. When
I'll
I was
actually
looking-
go back and look at that. That, based on my rubric, that might give you another point.
Oh, okay.
But yeah, I don't know why I did that. Maybe I just assumed you missed it because I had a bunch of other people give me 4 that had those backwards.
Oh, okay.
Maybe I just got it. No, you were right on everything except that careless there.
Yeah.
Yeah, that'd probably give you a point back.
Okay. Thank you.
Yeah.
Mr. Hurry.
See you, man. What's up, guys?